Hello and welcome to Mr. Davis's classroom. This is Algebra 2, and today we're going over quadratic equations. That's lesson 4 or 5 on pages 226 through 230. All right, let's jump in. We're going to be talking about zero of a function. This is when y equals 0 and it crosses the x-axis. Other names for this is a root of a function, zeros, roots, or x-intercept. Our book uses zeros, so those are the ones I'm going to be trying to use mostly. But if I say root or roots or x-intercept, you should know what I'm referring to. The reason why it's called zeros of a function is because if I just draw a quick xy table here and a quadratic like this, these values here are 0 for y. Right, that's where y is equal to 0. So that's why it's called zeros. Right. So when you think about this is where y is equal to 0. All right, zero product property. Well, if we have a times b is equal to 0, then we either have a is 0 or b is 0. Right? And this makes sense because, like 0 times 4 is 0. And let's say 5 times 0 is 0. So one of those two has to be 0. Right, one or the other. Well, this expands for problems like this. If 0 is equal to x plus 2, parentheses, x plus 7, parentheses, then we know that either x plus 2 has to be 0 or x plus 7 has to be 0. One of those two things has to happen. This is problem 1. It's like problems 9 through 17. Solving a quadratic equation by factoring. What are the solutions to the quadratic equation? Now, last one we did factoring. And I told you there was a reason for it other than just factoring for the sake of factoring. So, here what we're going to do is we're going to find a solution to this. Right? This is equal to 0. We want to find what the value of x is. So, first thing we need to do is factor. Well, the a value here is 1. Which tells me I can just use factor sum. So, we need to find factors of positive 6 and needs to add to negative 5. So I'm going to just write that 6, negative 5. Okay. So some factors of 6. How about 3, 2? All right, 3, 2. 3 times 2 is 6. 3 plus 2 is 5. Now you would think that would work, but it's negative 5 and that's a positive 5. So I need to change this to how about negative 3 and negative 2. A negative 3 times a negative 2 is a positive 6, but when you add them, it makes a negative 5. So it looks like negative 3 and negative 2 is my solution. So here I'm going to split apart my x's. Minus 3, minus 2. And now the part that is different from the last chapter is we have equals 0. Now, the zero product property states that either this first term has to be 0 or the second term has to be 0. So either x minus 3 is equal to 0 or x minus 2 is equal to 0. And I could solve these independently. So I can say plus 3, x is 3, or plus 2, x is equal to 2. So it's either x is 3 or x is 2. There are two answers to these problems. All right? Two answers. These ones you should be getting two answers to. All right. So factoring is probably the shortcut way to do it. And let's talk about a different way. Here it says solving a quadratic equation by graphing. What are the solutions to the quadratic equation? 2x squared plus 7x is equal to 15. Well, this one, we could try factoring first. We'd say, hey, maybe a GCF, but 2 doesn't go into 7 or 15. So it doesn't look like we can do it. We could probably try AC, but I don't know if we'd be able to get it factored nicely. So we're going to use a graphing calculator. Graphing calculators will always give you an answer. The only difference is a graphing calculator sometimes is not the quickest way. So first step is always, we want a 0 out here, right? We're finding the 0 of the function, so we want a 0 out there. To make that 0, we can minus 15 to both sides. And that'll give me 2x squared plus 7x minus 15 is equal to 0. So now I have a 0. So what I'm going to do is I'm going to take this equation and use my graphing calculator. So let me bring up my graphing calculator. All right, I want to graph it, so I'm going to go to the graphing right here. And I'm going to type it in, which was 2x squared plus 7x minus 15. I'm going to enter and see what that looks like. So, just looking at the graph as a whole graph, it's not so good. I'm missing a few things. I'm missing the vertex right down here. I don't get to see the whole graph, but we don't want to see the whole graph. What we want to do is find the zeros, right? And how many answers should I have? I should have 2. So there's 1, 2. So I have my 2 zeros. So this will suffice for what we want to do. So what we want to do is we want to find those 2 zeros. We find those in the menu, and we want to analyze number 6. And we want to do a 0, so we're analyzing a 0. Now, these dotted lines, remember, we're always sandwiching. So I'm going to find this left one first. So I'm going to go a little bit left, a little bit right, and sandwich it. See? And my answer is -5, 0. And we have to do it a second time. So analyze graph, 0. I'm going to sandwich this one. My 0 is 1.5. So my zeros are -5 and 1.5. So the solutions, right, are x equals 5 or x equals 1.5. 2 solutions. All right, 2 solutions. All right, so that's graphing calculators. Graphing calculators are a great tool, but they're a little bit longer than if we know how to factor it right off the bat. Alright, this is problem 4, it's like 36. Mark Twain wrote The Celebrated Jumping Frogs of Calaveras County in 1865. Frog jumping competitions have been getting more popular. Here we have an equation of one frog's jump, where x is distance in feet from the jump start, and y is height in feet. So what we're going to do is we're going to use a calculator to solve a few things. A is how far, B is how high, and C is a domain and range. So first off, let's look at why we're using a graphing calculator. Well, these numbers are ugly. They would be very, very tough to deal with. So we're going to use a calculator first, and then after that I'm going to show you guys a by hand way that we might be able to do a little bit quicker. Okay. So let's bring up our graphing calculator again. Okay. I'm going to type in our new equation and get rid of our old one. So I'm just going to go up to f function 1, delete our old stuff, and type in our new stuff, which was -0.029 x squared plus 0.59 x. Enter. So it looks like this now. This isn't a very good window for us, so let's change this window. Yeah, let's change this window. So menu, window, and let's just go to window settings. Now let's think about this as a frog jumping thing. So a frog jumps, and it's jumping forward, so it should be able to start at 0 and go forward. So I don't know how far a frog can jump. I might guess wrong, but I'm just going to say 30, right, to make sure I get it in. I don't think a frog can jump over 30, but I might be surprised. Y is the height, right? A frog isn't going to be 6 feet in the ground, so I'm going to start it at 0. And the height, maybe we'll go to, I don't know, 15 or so. Sounds good to me. See, a little bit, I was a little bit high and everything on my graph, but yeah, I guess a frog wouldn't be jumping 15 feet, but it's good enough for what we want to do. If you want to fix the window, right, you can always go back to window and fix it. Maybe change this to 25, maybe this one to 5. That might work a little bit better. Yeah, it looks a little bit better, right? So this is our frog jump. Okay, I'll move that out of the way. So, a few things. One is, we want to find how far he jumped. Well, this is where he started, right? And this is where he landed. Now, thinking about what we've been doing today, this down here is a 0 or a root of our problem. So we're going to go to Menu, Analyze, and 0, just like we did before, right? And we need to sandwich it. So I'm going to sandwich it here. Right? And there we go. 20.3 and 0. 20.3. So that frog can jump 20.3 feet. Starting at 0, 20.3 feet gets there. So let's go back here. How far did the frog jump? It was 20.3 feet. Pretty good for a frog. Right. Next is how high did the frog jump? Right. Well, that's going to be up here at the maximum. That's right back where we were at Analyze Graph Maximum. Right? And again, we're going to sandwich. Right? And we get 10.2 and 3. That means 10.2 feet away from its start, they're going to be, the frog's going to be 3 feet in the air. So it's 3 feet. Right? And last is, what is a reasonable domain in range? Okay, a reasonable domain in range. So for domain, what we want to think about is x values. What's the smallest x value? What's the biggest x value? Well, a frog is always going to start at 0 feet, right? And it's going to move up from there. Right? So 0 is less than or equal to the x, which is less than or equal to the highest that a frog can jump. Some people might say infinity because of, a frog can jump forever, if there's a mutant frog or, if it was in outer space and it jumped, it would go forever. But here on Earth and everything, we might say, hey, maybe under 30, right, until they break that world record. So that's the domain, between 0 and 30, right? A frog can't go further than 30 feet. Range. Range is the height. So we might say, right, 0, and then is less than or equal to y, which is less than or equal to, I don't know, maybe 5 feet, right? The frog can't really jump higher than 5 feet. So that's reasonable domain range. Now these numbers here are kind of subject to interpretation, which means I might say 30, you might say 25, but we're both pretty much right? I might say 5, you might say 4, but again, we're both it's kind of interpreted. So these are reasonable, right? If you wrote 25 and 4, that would also be reasonable. And one thing that you'll notice is these domains and ranges, those are very similar to what we do for our window, right? Didn't we come in here and go to window settings, right? This could be a reasonable domain and range that we plug into the window. So when you think about domain and range, sometimes if it's easy for you to think about window, you can do it that way. All right, here's our homework on page 229. It's 9 through 17 all. I want these ones done by hand. These are going to be factoring. 27 through 35 all using graphing calculators. And 42 through 53 all, and that's using any method you'd like. All right. Well, have fun and good luck. Thank you for stopping by.